Hello guys, my name is Desmond and I welcome you to my lesson for today where we will be looking at mathematics. So ladies and gentlemen, as always, please do allow me to say it is very much important that I say it is very much important because what I'm about to say it's massively. Hey, massively important, ladies and gentlemen, that I say a day without learning something new. I'm telling you, that one, it is a day wasted. By so saying, honorable members, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Very much important, ladies and gentlemen, over there. So, I hope you guys are able to notice where I'm getting all this information that I'm writing down. So that's what we'll be looking at in today's lesson. And most importantly, guys, just in case if something is not clear, just make sure that you indicate. And most importantly, whatever that I'm writing there, just make sure that I'm copying it correctly. So let's see. Obviously, question number 5, the first question, 5.1, says simplify fully, and you are given all of this. Remember, guys, every time when you don't see an equal sign, it means you are dealing with an expression that you need to simplify. So you have this long thing that you need to rewrite it in its simplest form. Remember, you have this, which is what we call the cast diagram, which guides you in terms of in which quadrant does an angle fall. So let's see. Starting with this one, this is where you realize you are having a reduction formula. So let's see, in which quadrant does 90 minus 4? It takes you to the first quadrant. And in the first quadrant, sign is positive. Remember, all the trig ratios, 3 of them are positive in the first quadrant. So because it is along that complementary angle, or it is 90, this one, it changes to a cos. So that means we are now going to have cos of an angle, of which an angle in this case is represented by letter x. So that means we are having cos of an angle, and then let's see, cos into 180 plus, in which quadrant? 180 plus, it takes you to that, and in this quadrant cos is negative. So that is why inside the brackets, maybe let's say cos of an angle. So remember, you've got a plus in between, or a plus separating the two terms. So can you see, tan of an angle, you cannot reduce that one. That is why you are just going to write it as it is. So it doesn't need to be reduced. Also, cos of an angle, you just write it as it is. It doesn't need to be reduced. Let's see. What about this one of sine into x minus that? Okay, maybe let's say we are having that one being sine into x minus 180 degrees. And if I remember this one, we said, let's try to rewrite it nicely, such that we are having 180 either minus or a plus. So let's see, that means we might be saying a sine of, maybe let's take out negative to the outside and say 180 degrees, so that when you say that by that, it takes you back to that. So for us to end up having positive x, let's see if we have negative x in there. So now, can you see? It seems like we have written it in this format that we want it to look like. But most importantly, remember, assuming that the whole of this is just theta, so it's more like this thing, it looks like a sine of negative theta, even though this theta in this case is the whole of that. So I just want you to realize that when you have sine of a negative angle, I think we said we're just going to assume that from that zero, it takes you into the fourth quadrant. So it's more like a negative angle. It's an angle in a clockwise direction, and it takes you into the fourth quadrant. Then you say in the fourth quadrant, is sine positive or negative? In this quadrant, sine is negative. So that is why you are therefore, let's see, going to be having negative sine of an angle. But remember, in this case, we are not having a theta as our angle, but we are having the whole of this as our angle. So it's more like you're going to have negative of sine of 180 degrees minus that. Remember, all this work, it's actually to explain to you why you are just going to be writing inside the brackets.
Sir,
Yebo.
can you please try to wipe your camera? It's not visible.
Not visible. Let me try to do something. Just so that is clear. Let me try to do this. How about now? Is it still the same, or is it better now?
It's much better, sir.
Okay, 100%. So now let's see. What I was saying is, you will realize that what I've just explained there is that on this step, this part, you therefore write it as negative sine of 180 degrees minus an angle. Someone might be wondering, in which case do we have these corners of the brackets? That's if you know inside you're going to have the brackets. So you don't write something as maybe 2 plus let's say into x plus 1, you close. In this case, if you know you're going to have the brackets, you start with those of the corners, then you do those normal brackets, and then you do that. So now let's continue with our next step. But before I continue, what I've done there, did it make sense to everyone? Because if you don't get that part, it might be a bit difficult for you to continue. What I've done there, does it make sense?
Yes, sir.
Okay, 100%. So now let's see. I'm sure you guys are able to notice something. Maybe same time, let's just say this multiplying that, it ends up being, you see that negative there, so it's negative cos squared of an angle. Then you still have a plus there. Maybe at the same time, let's try to dissolve that term and write it as sine x over cos x. Multiplying, we still have that being cos of an angle. Most importantly, now you work out this one. So can you see sine 180 minus, it falls in which quadrant? Minus is the backward quadrant, which is that second quadrant where sine is positive. So that means it's positive sine x, which still has that negative. That is why you're still having negative sine of that x there. So in short, it seems like when you simplify or prove identities, you try to dissolve tan to sine over cos. If there's one, try to work it out as sine squared plus cos squared. If you have minus 1 minus sine squared something, you can still write it as cos squared something, or otherwise 1 minus cos squared something. So every time when you either simplify or prove, you just don't want to be seeing tongue. When necessary, you want to replace one with that sine squared plus cos squared. So let's see. I think now what we can do, can you see this one? In the meantime, we can just write it as it is and just focus on this side of that expression. Maybe we can cancel this and that. And now I'm sure you realize this multiplies that. But remember, you still have a minus there, or a negative, which makes it a minus. Then you are having sine squared of an angle. So can you guys see? Maybe let's try to work out those two. I think we can come up with one from those two. What if we take out negative to the outside and then we say cos squared angle? If we say plus, not cos, but sine squared of an angle. Let's see. If we say da ba da, it takes us back to there. So can you see? We do know very well that the whole of this thing is actually equals to 1. So it's more like finally our final answer is equals to negative 1. So that's how you score yourself 6 marks for that question. Anyone who's got a question, honorable member, or did it make sense to everyone? Are we now ready to move on to the next question? Yebono Maka.
You can move on.
Okay, 100%. So I'm just going to remove all of this. So this is a previous question paper. It's actually a November question paper. So these are the types of questions that you might expect in exam. And this was a question on a final exam question paper. So now they are saying prove. Most importantly, without using a calculator. So they want you to prove that sine of 315 degrees, when you multiply it with tan of 210 degrees, multiplying it again by sine of 190, the whole of that being divided by cos of 100 multiplying sine of 120 degrees. They're saying proof that it is actually equals to negative square root of 2 over 3. And again, this one is allocated 6 marks. Most importantly, since we are proving, I think let's try to focus on the left hand side and see what we can do there. Most importantly, you realize your angles are actually numbers and not letters. That's why you need to remember special angles. Special angles. I always remember those when I'm dealing with a situation where my angles are numbers. So let's see. You need to remember that all the numbers greater than 90, they need to be reduced. So that means we will need to reduce that angle. Now, in which angle does that number fall? It falls in the fourth quadrant. So let's see. That means we can say we are having let's see, sine of 360 degrees minus what? I think when you minus it by 45, it gives you 314. So let's see, what about tan? In which quadrant does this angle fall? I think it falls just after 180, which is in that quadrant. So in that quadrant, I'm having 180 degrees plus what? I think plus 30. Yes. So can you guys see? We are not changing anything. We are just trying to rewrite those angles using reduction formulae. What do we mean by reduction formula? It's more like we are trying to reduce these bigger angles to acute angle. What is an acute angle? An angle which is between 0 and 90. So now let's see, multiplying here, what are we having there? We are having sine in 2. In which quadrant does that fall? I think it falls in the quadrant of 180 degrees plus what? Is it plus 10? Yes. 180 degrees plus 10, it takes you back to 190. So you haven't changed anything there. So now let's see, what about that one of cos? One can still say this one cos 100. Now you notice that you have an acute angle which doesn't form part of the special angles. Remember, special angles is 30 degrees, 45 degrees, and then 60 degrees. So now you are having 10, which means this might need to look the same as that angle so that somehow they can cancel each other out if possible. So that is why for this one, I'm not going to take a long route and say 180 minus whatever, but I'm just going to say 90 degrees plus 10 degrees. So multiplied by, so let's see, with this one, can I do it using the 180? Yes, I think if I say 180 degrees minus what? I think when you minus 60, is it 60? Yes, when you minus 60, it takes you back to that same angle. So can you guys see? You haven't changed anything. It's like you're having sine 4 and you just rewrite it as sine into 2 plus 2. You know why you are writing it in that format. So now we can start reducing. Sine of 360 minus 45 in this, let's see, in this quadrant is sine positive. No, it's negative. So that is why you're going to say negative sine of 45 degrees. Most importantly, inside the brackets, multiplied by, so let's see, tan 180 plus, it takes you in the third quadrant where tan is positive in that quadrant. So you don't need to put it inside the bracket. So let's see, sine of 180 plus takes you into the third quadrant, and in that third quadrant sign it's negative. That is why inside the brackets you can say negative sine of 10. Now let's get to this one. Remember, when it comes to this one of 90, so that means when you're dealing with 90 and 270, that's when you have some things changing there. So let's see, what are we going to say in this case? I think this is where we say a 90 plus, it takes you in which quadrant? 90 plus, it takes you in the second quadrant. So in the second quadrant is a cos, a positive or negative, cos it's negative. But remember, because it's 90, it has to change to its cofunction. So let's see, that means you're going to have negative, then it changes to a cofunction, then you're having 10 there. Most importantly, inside the brackets. So now this one, 180 minus, it takes you in the second quadrant, where in the second quadrant sign is positive. No need to put it inside the brackets. That is why you're just going to say sign of that. Before I continue, am I not losing you there, honorable members? Luyanda, are you sure I'm not losing you there, honorable member?
I had lost connection, sir, but I'm back.
Okay. I see Tabile is on the line. Tabile, Am I not losing you there, honorable member? Are we still together there?
Yes, sir. I understand what you're doing.
Okay, 100%. So now let's continue. Hey, can you guys see that those two, they cancel each other out already? So that is why I can now scratch those. So let's see. Remember, this is where now you need to draw those. Let's see. I can still remember that the one for 45, you have 1 there, and then square root of 2 there. And then you have this one, I think 30 is up there, 60 is there. What did we have there? Was it 1 square root of 3 and then 2? I think this is what we had for the special angles. Remember, it's not given to you on the formula sheet. So you need to know that one by heart. Very, very much important, ladies and gentlemen, over there. So now let's see. Sine of 45. Sine we know is opposite over opposite over a hypotenuse. Meaning you still have that negative there. Opposite is 1 over hypotenuse is square root of 2. It is multiplying tan of 30. So tan of 30, that means now opposite is 1. Opposite over adjacent. So that means we are having 1 over the root of 3 divided by sine 60. So let's see. Sine 60 is sine of 60. Sine is opposite over hypotenuse. So I'm thinking there, opposite is the square root of 3 over 2. Yes. Yes. So now, let's see. I'm not sure if I lost you, honorable members. Are we still together there, guys? What I've done up to this point. Are we still together there?
Yes, sir, we're still together.
Yes, we are still together.
Okay. 100%. So let's see. Let's see. From what I can do now, it seems like we are having that multiplying that. What if I say -1, then over the root of 2, which is multiplying the root of 3, and then you divide by the whole of that, being what is that? Is the root of 3 over 2. Where now you can replace that with a multiplication. Obviously, that one you know, meaning you are therefore going to have 2, the root of 3. And then now that is multiplying that is multiplying that. So it's more like you're having that negative, that times that, it gives you 2 divided by. Obviously, you have the root of 2 and then that multiplying that inside. So it's more like you're having the root of 9 because is 3 multiplying 3, which is 9. And then now, what is the root of 9? Square root of 9. Square root of 9, I think, is 3. Yes, I think it's 3. So now it's more like you're having a, wait, not the root of 3 there, but the root of 2. Let me just quickly correct that. Yes. I think this is what I wanted to do. So it's more like this thing. It's actually -2 over 3, the root of a 2. I'm just not sure if you guys understand what I've done up to this point. Before I continue, what I've done up to this point, does it make sense to everyone? Because this is where examiner is trying to test your understanding of SATs, your understanding of square roots, which means apelele. We don't want to be seeing square roots at the bottom. That is why you're going to multiply the whole of this thing by square root of 2 over square root of 2, because this thing is the same as 1. So it's more like you haven't changed anything there. And most importantly, when you multiply square root of 2 times square root of 2, it's more like you're saying square root of 2 times 2. And 2 times 2 is what? Is 4. What is square root of 4 is 2. So it's more like this is multiplying that. So you are having negative 2 square root of 2 divided by, you still have this 3. And then this times that, it gives you square root of 2 times 2 being 4. And then square root of 4 is what? Is 2. Maybe let me put it inside the brackets as 2. And then now you realize that this 2 cancels with that 2. So it's like finally you are having square root of 2 over 3. And this is now the final answer of that question, which means, oh yes. It wasn't actually a simplify, but we were actually trying to prove that the left hand side is equals to that, and most importantly, without using a calculator. So now that means this being the left hand side, it's equals to the right hand side. Did that one make sense, honorable member? Are you sure I haven't lost you on that one, Pantubagiti?
All good.
Okay, 100%. So let's see. Very quickly, let's try to move on to the next question. Remember, guys, this lesson is being recorded, which means you will have an opportunity to catch it up. So let's move on to 5.3 and see what we are having there. This is a Cartesian plane, and we are having something similar to that, where they say this is R, obviously that is the Y and the X axis. Then we have that angle, which is being called angle alpha, and again we are having that angle, which is being called angle beta. Obviously, this is the point which is called the origin being 0, and most importantly, we are having this point which they call it point P. Again, we are having T there. So let's see, the statement says in the diagram below, R, it's a point in the first quadrant, yes, such that T O R, angle O being that one, it's alpha, yes. O R or R O, O R or R O is extended to P. Oh, so that means this length is now extended to P, such that OP is actually 2 times OR. Oh, so that means from there to there is twice that distance. Maybe so that means half of that distance, it's actually the same as from there to there. So if you think about it, honorable member, before we even go far, they are simply saying, if you know the distance from there to there, let's say is 2, that means from there to there, is 2 times 2 being 4. Okay, let's see. Now, saying TOP. There is T, there is O, and then there it is P. There is the angle being a beta. Okay. Now they say it is given that. I think we need to write this one down. It is given that a sine of alpha it's equals to 3 over 5. Most importantly, before we can even start looking at the questions, let's try to complete a right-angled triangle. Remember, we know that sine is actually opposite over sinoa. Sinoa. Opposite over hypotenuse. Remember, on a Cartesian plane, we are dealing with x, y, and r, with y being opposite, this one adjacent, this one being hypotenuse. So now we can use the theorem of Pythagoras to determine the unknown, because we notice that actually y it is 3 and then r it is 5. What about x? So that's where you can say, you remember that r squared is equals to x squared plus a y squared. What are we having? We do have r, which is that, and then x is what we're looking for, plus y is what? Y is 3 squared. So it's more like x squared is equal. This is 25, this is 9. What is 25 minus 9? Let's see, is it 16? 25 minus 9, yes, it's 16. So that means this is equals to 16. Now you say square root on both sides so that you get your x. X is plus or minus square root of 16, which is 4. So the question is it positive 4 or negative 4? In this quadrant, x is positive, meaning x is equals to positive 4. So now you have completed all the sides of a right-angled triangle. Don't erase this after you've worked it out. Leave it there. You might score some marks on that one. So now let's move on to the questions. So can you see? The first question says, without using a calculator, most importantly, determine the value of tan of alpha. That's what they want you to determine. Tan of an alpha. You need to remember that tan of that same angle having these values, the ratio for tan is y over x, which is equals to what? What is y? Your y is 3. What is x? You just calculated it. So that is why I was saying don't erase it. Because if you don't erase it, you will get, out of this question being allocated 3 marks, I am going to give you a mark for correctly substituting into the formula for theorem of Pythagoras. I'm going to give you a mark for your x value being 4. And lastly, I'm just going to give you 1 mark there. So that's where you get your marks on that first calculation, which I said do not erase. Did it make sense to everyone, Libandla la kaNkulunkulu? Or is there anyone who's got a question on that one?
No, sir.
Okay, 100%. So now, very quickly, let's try move on to the next question. let's see, 5.3.2. The next question says the value of sine beta. The value of sine beta. Sizoyenza kanjani le nto le? But I think, honorable members, if you think about this thing, you will realize that from that point there, if you go up to that point there, that is 180. And that 180 plus this smallanyana angle, that is your full angle called beta. And you do know very well that where you have this line, and then now you have a line crossing, this angle being angle alpha, it is the same as that angle. What is that called? I think something, vertical opposite angles being the same, something of that nature. So you guys will actually realize that from there all the way up to there, it's actually 180 degrees. And when you plus it with this smallanyana angle, it is therefore a full angle. And that full angle, it is the one that is called a angle beta. Which means actually angle beta, it is actually the same as sine of 180 degrees plus that alpha. This angle beta, it is the same as the whole of that because it is straight line being 180 plus that smallanyana angle. And that smallanyana angle is vertically opposite to this one, which is equal angle. I'm not sure if you guys are able to notice something. 180 degrees minus alpha, it's a reduction for, so 180 degrees, no, not a plus, but not a minus, but a plus. It takes you in which quadrant? In this third quadrant. And in the third quadrant, sign is negative. So that is why we're going to say negative sine of an alpha. Now it's easier to work with because we know the values for alpha. We know for its x, that is that, that is that. But now, what is the ratio for sine? Is opposite over a hypotenuse. Meaning we are having negative. What is opposite? Let's see. There we are having 3. What is hypotenuse or r? It is equals to 5. So that means it ends there. And that is how you score yourself 3 marks. So with you noticing that, I'm telling you, I am going to give you a mark there. With you correctly reducing that angle, you will definitely score a mark there. And finally, the last obvious step, you will definitely get a mark there. And that's how you get your full 3 marks. Did that one make sense to everyone, honorable members, or did I lose you somewhere on that one? I'm not sure, Muleboge, if we're still together on that one.
No, we are still together.
Members, in case if I'm losing you, raise your hand. So I just got a response that we are still together on that one. So I'm just going to remove all of this as we move on to the next question. So also in grade 12, you will need to expect the same type of questioning, but it might be a bit tricky. Not necessarily tricky, but it's going to be different. It's going to be on an advanced level. But most importantly, you will be given a background so that you fully understand. If you want to know whether you're making progress or not, that's if when something is being explained, when you fully understand That's how you know you are on the right track. But if you completely don't understand, it means there's something that you are missing. It's not that you don't understand, but you lack information or you lack the background, which is where you need to catch up in case if you missed introduction. So let's see. This question says the coordinates of P. Most importantly, if you do this, you sort of have an idea of how your final answer should look like. You need to have the x value and the y value. Those are the coordinates. Then you know that actually whatever that you do, you actually need to try and find the values. Maybe let's see. I think on my side, I'm able to notice something there. If you guys remember, we are having this same line being extended by 2 times. So that means this is what we are having. A bigger triangle and a smaller triangle. And I think we do know very well that from here to there, it is 5. So that means from there to there, they said 2 times, meaning what is it? Is 10. The bigger r is equals to 10. And then this smaller r is equals to what? It's 5. I'm not sure if I'm losing you guys on that one. But can someone just indicate if we are still together there, honorable members? Do you guys understand what I've done there?
Yes, sir, we're still together.
Yes, sir.
Okay, 100%. And most importantly, I'm just not sure. Remember, this triangle, it's exactly the same as that. But now the difference is that this has been extended 2 times. So you are now having this triangle having that, and then you also have this side. We already know that side is what? What is it? Is 3 or it's -3. In this case, you're going to say -3 because it's actually below. And then what is it? What you might not know, it is obviously this y there. But I'm just suspecting that this thing is going to be very easy. Let me try to prove this one. So it's more like you can do this thing of the ratio Bantubakiti to say, remember, this is that y of small triangle. This is y of big triangle. This is r of small, r of big. So what if you say, maybe let's say this y of small triangle over the big y. So that means you're going to have small r and then the big R. Let's see. What is what is the y of small triangle? That one, I think it's -3. Am I doing correct things here? I think so. Let's say over y of big triangle. That's where maybe we can say y it's equals to, let's see, what about r of a small triangle? That is 5 over the big one is that. Yes. Then now you can cross multiply. So it's more like you're going to say that times that, it gives you -30 equals to that times that, it gives you 5y. So that means y is going to be equals to 30 divided by that, and it gives you -6. So what I suspected was, if this one, the small triangle, it's -3, since this thing is twice the distance, possibly from the origin to there, it is -6. Hmm? Wait. Not that, because this is not -3. This is the one which is -3. Yeah, this question, I think possibly examiner is going to catch you with the confusion involved with that question. But what I'm trying to explain is that if this is 3, possibly this is -6. Yes, this is what I'm trying to say. And again, if from there to there, what is that? It's 4. That means possibly from there to there, it is -8. Yes, this is what I'm trying to say. Reason being, you have a triangle having that, and then now it is being extended by 2 times. So it's more like a you are having this triangle which is now being doubled in size. I'm not sure if you guys understand what I'm trying to say there. So in short, I'm actually saying the x value for that p there is therefore going to be that -8, and the y value is going to be that -6. These are the coordinates of that point P. I'm not sure if it makes sense, guys, but I'm willing to re-explain this one because I realize it's not that much difficult. It's just that it might be confusing. This is where examiner is going to catch you. But just indication from your side, what I've just explained there, does it make sense to everyone, honorable members? Or does it need a re-explanation? Did I lose you somewhere on that one? Hmm? Guys, are you still there?
Yes, sir.
Yes, sir.
So, just before I move on to the next one, that yes, does it mean you understand what I've done there? Because you might be saying yes, answering to a question of you still there. Yes, you are still there, but do you understand? Yebo noma cha? Okay, I'm just going to make an assumption that it is clear, because if there was a question, obviously someone was going to stop me and ask a question. So I think it is not complicated, but it is just confusing. So if you manage to pull yourself together, stay calm, and work it out, you will manage. So let's have a look at that last question there, where you need to prove the identity. They say sign that, a minus time and that, multiplying cos squared of an angle, the whole of that divided by a cos of an angle minus 1 plus sine squared angle. You guys need to be careful of something. Sometimes that angle might not be the same. Here you might have x, let's say there you have y. If angles are not the same, you cannot work them together. You need to make sure that those of theta, you work them together, those of alpha or beta, you work them together. So let's see, maybe let's have a look at the left hand side and see if we can work out that, because we realize we are having term that we can break it, we're having that we can break it, that we can break it, also one we can break it. But let's see, where do we start in this case? So you can still write sine angle as it is because you cannot do anything to that. And then you can say minus, let's see if we rewrite this one as that, multiplying cos squared of an angle. Remember, the whole of that, it is the one that you divide by cos of an angle. You have your minus 1 there, plus, maybe this one, let's write it as sine squared of an angle for now. Why? Because we don't have a reason to change it at this point in time. So that is why for now we can just write it as it is. Are we still together on that one, honorable members? But I think we are still together there.
Yes, so we are.
Okay, 100%. So let's see. Sine of an angle, I think let's cancel those that cancel. If we cancel that, it cancels 1 from that. So that means we are having minus sine of an angle times cos of an angle. The whole of that, it can be divided by. So now, can you see, this is where you need to be careful. When it gets to this stage, this is where you realize you are having cos, you have 1, and then you have that. So now if we say let's change this, the reason why we change it is because we realize if we can change this one, then we're going to have another cos which can be worked out with that cos there. So that means you can say cos of an angle minus 1 plus, you know that this thing is actually the same as 1 minus a cos squared of an angle. So can you see, now we have a reason to change this one. What is our reason? It's because we want at the bottom to just be having cos, so that we can see if we can work them out. I'm not sure if you guys realize that here we can actually take out sine as common factor. And you're just going to have 1 minusing a cos of an angle there. Negative 1 plus 1, I think those cancel each other out. And then you remain with cos angle minus cos angle. So now you see you've got common factor being cos of an angle into, then you have 1 and then minusing a cos of an angle. I think now it's obvious that the whole of this can cancel with the whole of that. And then sine over cos, that is tan of an angle. Hey, I think this thing, you can now make a conclusion to say, therefore, of course, the left-hand side, you've just proven that it is the same or equals to the right-hand side. I'm telling you guys, if you do that, I am going to give you full marks, being 4 marks for that question. Anyone who's got
Can
a
I
question,
ask something?
or was it clear?
Yes, I want to ask something. I'm confused a bit, but where I'm confused is where you see cos theta minus 1 cos theta squared. I get, yeah, A.
Mm-hmm.
So I want my negative 1 le negative 1 di cancel. 1 le 1 di cancel.
Yes.
So how do okay. Oh, ne ke batla ho itse ha di fetso cancela 1 on ke squared. Okay, bon. Ne ke batla ho itse ha e fetso cancela ya 1 ka mohare motse re kae. But now I understand ka gore nna
Oh yes,
Okay.
range has
Yeah.
common factor.
Okay. Ne ke batle ke ra 1 ka mogare ke yone ke buang ka yone.
Yeah.
Ke re ke yone ne ke sa
Yeah.
tlhaloganya re tswa kae mara no ke a bona.
Yeah. So get
Okay.
that one there, that invisible one there. And there's another one there, but that one obviously, yeah. Waibona mos
No ke a e
taken out
bona
is
no.
common factor there. Yeah.
No ke a e
Oh
bona.
yes, no. Now I get your point. So I think yes, because now we are having ones there, and we still have another one there. Yeah, no, I think I get your point on that one. So I think it would have been best if I've shown that step, so that also in case there's someone wondering, then they understand where you are coming from. It is a valid question. Someone might be writing and not trying to understand where what is coming from. So let's see. Yes, I think if I've done it that way, everyone else is going to understand where your question was coming from. But honorable members of the opposition, Tiara Luyanda, are we together that side? Aphelele. I see Okutle is on the line. It seems like Okutle recently joined. Busisiwe is there. Mzozozo is there. Tabile. I'm not sure, Tabile, if we are still together, honorable member. Akanya is there. Akanya Utulile. Leslie them are Leslie's. Did you guys understand what was the business of today, honorable members? Did that make sense to everyone? Forces on the
Yes,
ground.
yes, sir, it's clear.
100%. So, ladies and gentlemen, I'm telling you, this is where Mzozozo will allow me to run away and say, thanks very much for joining. My name is Desmond. You guys have a very good night. But I think I forgot something, guys. I think I forgot something. Can someone remind me? What is it that I forgot?
The code of the day.
Yes. What would be today's code, honorable members? I think, guys, did I ever ask you to comment with what you have done and what you are currently doing? I'm just not sure if I've got that information. Can someone just remind me? Do we have that info for grade 11s? Hmm? Maybe I don't. Okay, then it's fine. The code for today, honorable members, comment with what you have done up to this point, not with our lessons, but at your school. Someone might say, um, what is it? If you have done functions, then say functions, number pattern, and then if you are currently on trig, then say trig. So that will be the code for today. Then we'll be able to know what you guys have covered and what you are currently doing, so that also on our side we know what is going to be our next lesson. So grade 10, 11, and 12, we are now doing what is supposed to be done under term 1. So it's more like we're trying to trace what you guys should be doing during term 1, and that's what we are focusing on. So that is why I'm saying comment with what you have done, and the last one being what you are currently doing. So guys, have a very good night. My name is Desmond, and I'm God.